know what causes the seasons to change? Well, as Earth revolves around the sun, sunlight strikes different parts of Earth at different angles. These changes in the angle of the sunlight cause the seasons. The angle that the sunlight hits Earth changes during a year because Earth's axis is tilted. As the Earth revolves around the sun, the tilted axis always points in the same direction. Let's focus on the different seasons in the northern hemisphere. In the winter, the northern hemisphere is tilted away from the sun, causing colder temperatures, even though Earth is closer to the sun in its orbit. In the spring, when the northern hemisphere is in this position, temperatures are generally mild. In the summer, the northern hemisphere is tilted toward the sun. This causes the temperature to be warmer, even though Earth is farther from the sun in its orbit. Then in autumn, when the northern hemisphere is in this position, temperatures are typically mild. The seasons in the southern hemisphere are always opposite from the northern hemisphere. This is because when the northern hemisphere is tilted away from the sun, the southern hemisphere is tilted toward it. And when the northern hemisphere is tilted toward the sun, the southern hemisphere is tilted away from it. So Earth, revolving around the sun, causes seasons. How do you think the changing seasons affect life on Earth?
Hello, I'm Mr. Douglas. Gravity. Gravity is a force of attraction that exists between any two objects that have mass. The strength of gravity depends on the mass of the objects and the distance between them. In these diagrams, the arrows represent the gravitational force. Thicker arrows indicate stronger force. You can see in this upper diagram that if the mass of at least one of the objects increases, the gravitational force between the objects also increases. This lower diagram shows that if the distance between the objects increases, the gravitational force decreases. This is the law of universal gravitation. All objects are attracted to each other by gravitational force, and the strength of the force depends on the mass of each object and the distance that separates the objects. Everything on Earth is pulled by Earth's gravitational force. Think about two objects on Earth's surface, such as rocks. Why don't these two rocks get pulled together by the force of gravity? Compared to the gravitational force of the Earth, the gravitational force between the rocks is not large enough to cause any motion between them. Gravity was important in the formation of our solar system. Scientists hypothesize that the solar system began as a nebula, which is a cloud of gas, ice, and dust. Over time, gravitational forces pulled these materials together into a rotating, disc-shaped cloud. The center of this spinning cloud gained more and more mass as more matter was pulled into it, and eventually it formed a star, which we call the Sun. Even though this new sun was very massive, it did not pull in all of the material around it. Some clumps of material within the ring of the disks were pulled together by gravity to form the planets. As the disk continued spinning, these planets were moving with enough forward motion to resist being pulled into the center. But the sun's pull on the planets does keep them from flying off into space. This balance between gravity and forward motion explains why the planets and other objects in the solar system continue to remain in the sun's orbit.